Imagine spending exactly 10 minutes floating near a black hole. You check your watch, turn your ship around, and head home, only to find that years have passed for everyone you left behind. To see how this happens, picture two identical, perfectly synchronized clocks. One is inside that spacecraft, and the other is floating far away in deep space. If you could watch both of them side by side, you would observe a physical discrepancy. The clock near the black hole is visibly ticking slower than the one in deep space. The hardware is functioning perfectly. Both mechanisms are working exactly as designed. Our basic human assumption about how reality operates is what fails to match the observation. We naturally assume time acts as a constant background force, a giant clock ticking at the exact same speed for every object in the cosmos. Modern physics shows that this universal clock is a fiction. Albert Einstein's theory of relativity provided the framework to explain why time behaves so strangely. Einstein proved that gravity dictates the speed at which time flows. Time is a physical property. When a massive object like a black hole creates intense gravity, it warps the actual passage of time in its vicinity. If you are the astronaut sitting inside that spacecraft, this gravitational warping remains hidden. Your internal rhythm feels ordinary. Your heart beats at its usual pace, and your thoughts form at a regular speed. You look down at your wrist, and the seconds tick by exactly as you expect. The digital displays on the ship's dashboard match your watch. Even as your ship drifts closer to the event horizon, the absolute boundary of the black hole, that localized feeling of normalcy persists. From within your own frame of reference, everything is behaving as it should. You cannot detect any slowing of time. The experience of time is local to your perspective. There is no physical sensation to warn you that your reality is dragging behind the rest of the universe. To see the distortion, you have to look from the outside. From the vantage point of an observer floating safely in deep space, that same spacecraft appears to be moving in agonizing slow motion. The direct correlation is clear. The stronger the gravity you experience, the slower your time passes relative to someone standing in weaker gravity. Think of it like two people watching the same movie, but one version is playing at a fraction of the speed. The difference only becomes obvious when they pause and compare notes. Both perspectives represent a real measurement of reality. The distortion exists only in the comparison between two different locations in space. We don't need to travel to a black hole to observe this phenomenon. We can measure it in our own atmosphere. Gravity manipulates time in all environments. It is a universal law acting upon everything. This diagram illustrates the relationship between Earth's gravity and the passage of time. It maps how clocks behave differently depending on altitude. Because gravity weakens away from the surface, a clock at a higher altitude physically ticks faster than one on the ground. Modern GPS satellites operate under these exact conditions. In orbit thousands of miles above Earth, their atomic clocks experience less gravity and tick faster than ground receivers. Scientists mathematically correct this constant time difference. Without these adjustments, the global network would fail. Humanity relies on the fact that gravity warps time every single day to navigate our world. These immense black holes act as cosmic magnifying glasses, exposing the invisible rules that govern the rest of the universe. Time behaves like a flexible fabric, bending and stretching in response to mass. The seconds ticking by right now belong to your specific location in space. Time behaves differently depending on where you are standing in the cosmos.